Alright, so welcome to the Defortune's Academy, where we interact and learn very sweetly, where we learn all engineering and science courses. So for yesterday, we were able to do indices. So please, if you were not there, if you did not get that video, try and go back and try to get the videos done. So for today, we'll be doing Physics 101, and under it, we'll be doing a topic called dimensioning. Dimension is actually a very, very simple course, and I'll make it more simpler for you. Just follow up. So dimension in definition, dimension is actually a symbolic way of representing quantities. Simple. It's actually a symbolic way of representing quantities. Now, we have two types of quantities in physics, and the first quantity we have is what? Fundamental quantities. Fundamental quantities. Now, definition. So fundamental quantities, these are independent quantities. These are independent quantities. That means these are quantities that does not depend on another quantity. They can stand alone. That's number one. They can stand alone. They are not gotten by a simple combination of any other quantities. And that first quantity under this is what we call what? Mass. Note, we'll be using a notation. There's a notation we'll be using. That notation is called MLT notation. That notation is called MLT notation. So where M is your mass, L is your length, and T is your time. Now there's something I want you guys to understand by the word length. Length here in dimensioning is not practically telling you about your ruler. It's telling you about the distance between 2 points. So let me bring this out. So if I have a rectangle, as I said, I have a point here, I have a point here, I have a point here, and I have a point here. Please, there's something I want you to note. This place is called a vertex, not an angle. These 2 points here, where 2 lines meet, is called a vertex. So the angle is between here and here. These are the angles between here and here. These are your angles. So between this place to this place, there's a space. There's a space between this place, and that place is called, between here and here is called a distance. A has passed through a distance to reach B, and in distance you have it as M. That is why length here, the dimension is also at what? M. Just know that. So anywhere you see distance is still what? M. It's still where M, which the dimension is what? L. Displacement, the dimension is also what? Dimension. Displacement, the dimension is also what? L. Note these things. So you have mass. I'll give you the SI units. Okay, let's call these quantities. Let's call these SI units. What is the full meaning of SI? International system. That means we have other systems that are not international. So the other systems, you can call them normal units, like kilogram. Okay, let's be doing, we'll solve more better. This is what? Dimensioning. These dimensions. So I'll use 1 stone and kill 2 birds at the same time. So please follow up. I'm going to kill this very fast. SI unit for mass is kilogram, not grams. So that means gram becomes just the unit, not SI unit. Do you understand? Dimension here, just take the first letter for the first 3. Remember, I told you the notation we are doing is what? MLT notation. So we are taking the first letter from M. Now we have the next one as what? Length. Length, the SI unit for length is what? Meters. As I said already, it's meters. Here we have meters. The dimension takes the first letter, which is what? L. We have the next one as what? Time. What is the SI unit? Seconds. We also have other minutes, also other units as what? Minutes and hours. But the SI unit is what? Second. So we take the first letter. So apart from this, the rest does not have the dimension. For your first semester exams, you don't need the rest for now. And for your Jamb, you don't need the rest for now. So just take these first 3. After this, we have the next one as what? Temperature. We have the next one as what? Temperature. Now, temperature is what? Kelvin. SI unit. Kelvin. Dimension. Nothing. We have the next one as amount of substance. Amount of substance. We have the next one as amount of substance, which is in mole. Dimension, null. We have the next one as electric current. Electric current is in what? Amperes. And dimension, null. We have the last one, which is luminous intensity. which is what? Candela in CD. So these are your 7 fundamental quantities you need to hold for your exams. You need to hold them. Note that these cannot be gotten from a simple combination of any other element. They are by themselves. They are independent of themselves. So take this down while we get the derived quantities. Derived quantities. Let's get derived quantities ASAP. I'm very sure you took this down already. So derived quantities. Under derived quantities, we have plenty derived quantities, but I'll just teach us 5. I will solve one question that will come out mostly in exams. Just one simple question under dimension or 2. Now we have here derived quantities. Definition. Derived quantities. Definition is, a derived quantity is actually a quantity that is gotten from simple combination of another quantity, or is gotten from a simple combination of the fundamental quantity we just finished, or it is a quantity that is dependable on another quantity. That simply means without fundamental quantity, no derived quantities. So let's get the first one, which is what? Area. Area. Now, area, let's clean SI unit. Area is what? When someone is talking about area, let's still take this rectangle to be an example. You have a rectangle this way. You have point A, point B, point C, point D. Remember the name I gave you for this place? What's the name again? Vertex. If you say vertex, that means you're correct. So I told you the name of this point here is called vertex. And the name of the distance between here to here is called what? Angle. Very good. So we have this point, we have this point, we have this point. We have this as a rectangle. Why? Because it has this side to be equal to this side. This side to be equal to this side. So practically it has 2 equal sides. Good. Now from here to here, which is the longest side takes the length. From here to here, which is the next long side takes the what? The breadth. So the longest side takes the length. Now look at this. I told you something about distance. From here to here covers a distance. And for distance, we have m, which the dimension is what? L. So that means for this place, my dimension will still be what? L. Then for the next one, here to here is also a distance between here to here. Between here to here is another distance, which from here to here, meters distance, which is still what? L. So I have times what? L. The formula is L times breadth. That is length times breadth. So if I have the length here to here as a distance, which is in L, times the breadth here to here, which is distance, which is still in L. From here, law of indices. Please, if you did not follow my previous law, go back to my playlist. You will see indices as one of the topics there. Go back, that is under math 101. Go back there and watch those videos so I can come back and understand this topic more better. Now, if I have L and L, law of indices says I should pick one and add the power. That means practically this invisible one here is another invisible one here. 1 plus 1 will give me what? 2. That becomes the dimension for this guy, area. I said I'm going to solve 5. We are going to do the next one. So let's go to the next one, which is volume. Volume. When we are talking about volume, practically we are talking about something similar to a cylinder, which we have here. When they taught you volume, they taught you that topic under a topic called capacity. So we are talking about volume. We are talking about the amount of liquid a particular container can carry. You understand? So let's call this a container with liquid inside. You understand? Now from here, you bet with me that the length, the distance between here to here is not the same distance between here to here. So, and there's a distance between the top of the container to the bottom of the container. So it has different names. So I can call this side, for those that were taught projection motion, you have been taught motion as a whole. You use G when there's a height, yes or yes? So this height now, this place becomes my height. Why? Because it's from the top to the what? To the bottom. So I have here as my height, H. Now, if there was no height, I would have given this place as my length because it's the longest side. But there's another long side here, which I can take it as the what? L before the breadth here. I can practically say the measure of the external body and the measure of the internal body. If you open a cylinder, you used to see something like this at the surface, at the bottom of it. Sorry, at the bottom of it. It's not the same measurement with the outermost part. So there we have the height, the length, and the breadth. So the formula becomes what? the length times breadth times what? Height. Now let's consider these three things. If here is the length, I can call this point A, point B, point C, point D, point E, and what? Point F. From here to here is a distance, and distance is in meter. Meter is in what? L. I'm doing the dimension now. Now, from here to here is a distance, and distance is what? M. Dimension is what? L. Times here to here is a distance. Distance is M. Dimension is what? L. So if I have this, law of indices says, when I have this same thing, pick one and do what? Add the powers. So 1 plus 1 plus 1 gives you L cube. Okay, so I believe you've understood that. We have 3 left. I'm going to solve 3 more questions under this, and I'll bet you to go and solve any other one, and you understand. So after this, let's get acceleration. I'm going to jump, or let's get density. Alright, so let's go to density. Now I'm talking about density. Density comes from the word dense. So when you hear the word dense, it's talking about the mass. And so between water and air, which one is dense or which one is denser? So the formula goes thus: we have mass all over what? Volume. That's the formula. We have mass over volume. Now, from what we have done, what is the dimension for mass? Is what? M, right? M. All over. What is the dimension from volume from what we have just done? We have that is what? L cube. Now this is the simplest way to solve something like this. Now you bet with me that I have A all over B. I can still call this 1 all over B times A. You see the same thing. This shows you that there was an invisible one with A. So if I expose this, this is what I have. So simple phenomenon here. Shift the numerator one side times the invisible one that was with M. 1 all over what? The denominator. As simple as that. As simple as that. Now from here, I can invert this. Recall that A raised to the power of minus 1 is the same thing as what? 1 all over A. How? There's this law I taught in the previous class. Please go back to my previous lesson under indices and follow up. There's this law I taught you. Something like this and this. Now, when we were solving product law, we added powers. When we were solving division law, we minus powers. So now that there is minus, we use the brother. If someone is giving you 2 raised to the power of minus 1, use the brother of this guy, which is division. The minus is no more there. What are you seeing? 2 raised to the power of 1. Bring it down, 2 raised to the power of 1. Balance here with 1. That means 1 is a number of balance. If I have something like this, I can choose to balance this with 1. Do you understand? That's the same thing I did here. So somebody is giving you this 5 raised to the power of minus 8, and you want to remove the minus. Change the minus to what? Division. It becomes 5 raised to the power of 8. You have 5 raised to the power of 8. Balance here with what? 1. So if I want to invert that, I'll turn this denominator up again and make the division the brother of it. That is, I can call it the derivative of this guy. I have 5 raised to the power of minus 8. I've gotten it back. So from here I have M times, if I invert this, I'll bring first the denominator, division sign turns to its brother, which is this. So from here I have M L minus 3 as my answer, as the dimension for density. That's the dimension for density. Let's take one more. Or is this 3? This is 3, so we take 2 more. Let's take 2 more. Now there's something, I'll take one hard one, I'll take one simple one, then you take one hard one. Now you can go and do the rest. Now let's get acceleration. Acceleration is what? Change in velocity all over change in time. Now look up, this is a symbol for change. Your textbook can also do dv all over what? dt. It's still the same thing. So that means this thing simply means what? Delta. Which means what? Change. Which means change. It means change. So I can say change in velocity. Now the concept of this is that when you hear the word change in velocity, know that there are 2 things. If a body was moving in a particular velocity this way, and it now change in velocity this way, or it was walking this way, it now change velocity, there was something was working on before. Now he has so when you're hearing the word change, it means there were 2 things. So remember, Or let's recall that there's a formula for velocity, which is what? Distance is what? M, and the SI unit is what? L. Time is what? T, all over T. The concept I showed you here is what? Bring L times 1 all over what? T. Invert this, you have L times what? T raised to the power minus 1 times it, you have L T raised to the power minus 1. That simply means velocity is what? L T raised to the power minus 1. I'll input that here. So I have that acceleration is equals to what? Velocity all over what? Time is what? T. In this case, since you're doing CBT, I'm going to teach you 2 ways you can solve this. I'm going to teach you 2 ways you can solve this. I'm going to teach you 2 ways you can do this. Now, if I have LT minus 1 all over T, look at this symbol. It is similar. Please, if I had here, let's say all over S, I cannot go and do any nonsense. I'll fail it. Do you understand? So, because if here was L, I will work with these 2. But since here is T, I'll work with these 2. So, what will I do here? There's minus sign here. Now, the law is that when you have this, you want to work it with this guy. T and T are the same. I have minus 1. Division here changed to his brother, which is minus. T is carrying invisible 1. So, it becomes minus 1 minus 1. Minus 1 minus 1. So I'll pick 1 T, I have equals to L, pick 1 T, minus 1 minus 1. I'll have LT minus 2. That is the CBT concept. You do it without doing any long step. Now let's use the normal concept. If I have T, the concept I just taught you now, I say shift the numerator, I have this times what? 1 all over T. That's a yes. So from here I have this minus 1 times. If I invert this, I have this. And from here, pick 1 L, pick one of your T. Work with the powers. What will you have? Minus 1 plus minus 1. Right? I'll put the other minus 1 in bracket. I have LT. Plus times minus is minus. So minus 1 minus 1. I have the LT minus 2. Giving me the same thing I had here. So you can use this for your CBT, which is short. You can use this for your second semester. One last one. I want us to solve a question that will surely come out. You solve 2 questions. In your exam, they will ask you to use dimension to prove a rule that it is correct, or prove a theorem, or prove a formula that it is correct. So that's where I want us to fly to. And you're done. Now there's a question that mostly come out, which is viscosity. Because you find the dimension for viscosity. Now viscosity has a formula, and the formula is what? Force over what? Area times what? Velocity gradient. And there's something I want you to know about velocity gradient, about the word gradient. What is this? Anytime you hear the word gradient in physics, know that it's all over length. So if I ask you time gradient, if I said for you time gradient, it's just talking about what? Time all over what? Length. It's the same thing. Velocity gradient, acceleration over length. Ampere gradient, if there's anything like that, ampere over length. So just know the concept about gradients. Alright, so from here, force. Let's go and get the dimension for force. Force is what? Force is mass times what? Acceleration. Please, yeah, I will not allow you to say acceleration due to gravity, because I have not specified if there is a height. So just call it acceleration. So here, mass is what? M, right? We solve acceleration to have LT minus 2. That's a yes. So by times this, I'll have M times LT minus 2 give me MLT minus 2. This becomes the answer. So I'm going to input that here, and I'll have MLT minus 2 all over. Area is what? L square times velocity is what? LT minus 1 all over. Length is still what? L. So I have this. I can choose to cancel this. I'll tell you the correct answer. You should know that AB all over A is the same thing as what? B. Because A cancel B. So that's the same concept I applied here. So if I rewrite, I have this LT minus 2 all over what? L square T minus 1. Now this is a simple concept. I just told you. You can choose to solve here under CBT method. That is, you want to solve with speed and accuracy. What will you do here? I have invisible 1 here. I'll take 1 minus 2. That means there's no M, I'll pick 1 M. There's L and L, I'll work with the powers. So I have 1 here. Division change to minus. So 1 minus 2. I have L 1 minus 2. I'll pick 1 T. I have number here, minus 2 minus minus 1. Look up again. Minus 2 division minus minus 1. So I have t is equals to minus 2 minus minus 1. So from here I have m, 1 minus 2 give me what? Minus 1. T minus, okay, minus times minus will give me plus. So I have minus 2 plus 1. And this will give me what? M L minus 1 T. This and this will give me what? Minus what? 1. This becomes your answer. Now let's use the normal proof I told you and check. If I shift numerator, I have ML T minus 2 times 1 all over L squared T minus 1. From here you invert. Now you have ML T minus 2 times, if I bring this up, it will become L minus 2. If I bring this up, it becomes only T. Now look up. If it was only 1 all over L, or let me shift this. Look up. If I have MLT minus 2 times, I can split this to have 1 all over L squared times 1 all over T minus 1. I can choose to have this. So if I take this, if I bring this, let me bring this up. I have MLT minus 2 times, if I invert this from what we have been doing so far, if I invert this, I have L minus 2, isn't it? Times, if I invert this now, I have T minus 1. Why am I getting the minus 1 from? Division itself was minus, it inverted. So this is the minus of division, and the 1 was already carrying minus 1. This is the minus 1 of the 1. So I have MLT minus 2 times L minus 2 square times this. Minus times minus will give you what? Plus. So you have just T. That's the same thing I did there. So from here I have M. There's no more M here, so I've already picked the M. L, there's another L here, pick one. 1 minus, okay, let's say 1 plus minus 2. I pick times, or here I can use dots. Do you understand? Now from here I pick 1 T. I have minus 2 plus 1. So from here I have M, L. Plus times minus give me minus. So 1 minus 2 give me minus 1. And I can just join everything. Minus 2 plus 1 will give me minus 1. Gives us the same answer we had here. So which one do you think will be okay for you? You can use this in your second semester and have your proof. The lecturer want to see that all you did land at the answer. So you can use this for CBT and have your answer very sharp and correct. So let's get let's get 2 questions under equations of dimension, and we are done for dimension. All right. We have this formula. We want to prove. They say prove this to be correct. Prove this to be correct using what? Dimensioning. So this is what you'll be asked in your first semester, your exams, your test, your Jamb. Paraventure, I can give you this. You say, prove this that it is correct. We give you options. Okay, let's play with it. The first thing I want you to do here is to bring down your perimeters. What is here? Distance. S is a symbol for distance. What is the dimension for distance, as I told you, is what? L, right? Now take this law, law 1. Now continue, take this law. Law 1. Numbers are dimensionless. That's one law. Numbers are dimensionless. What do I mean? The law is that what is in the right hand side, let's say if I had L plus L equals to L minus L. The law is that what is in the right hand side must be equal to what is in the left hand side. What is in the right hand side must be equal to what is in the left hand side. Or you can simply say what is in the left hand side must be equal to what is in the right hand side. Now look at this. What I want you to know, if I add 2 here, numbers does not affect dimensioning. This number is a constant. This sign is a constant. So take 1. Numbers does not affect dimensioning. 2. Signs does not affect dimensioning. So here might be plus, here might be minus. It's not your business. What is your business is the symbol here. Raise to the power of 1, raise to the power of 1, raise to the power of 1, raise to the power of 1 makes it correct. So the sign does not affect your solving. The numbers does not affect your solving. They are all dimensionless. Get that into your head. It will help you. They are all dimensionless. So let's do something. So let's bring this. I brought out the dimension for this guy. Next up is U, which stands for what? Initial velocity. Now, when somebody say initial velocity, final velocity, what are they attaching to the next? After this prefix, what are they attaching? Velocity. Whether it is initial or whether it is final, it has the same SI unit as far as it is what? Velocity. So that means initial here still gives me my same velocity. Time is what? T. Already on its own. Time is what? T. Half, I've told you it does not have any dimension, so just leave it. Sine already does not have any dimension. So I'll go to the next thing and see what? A. A is LT minus 2. T again is coming. T is what? T here, which is time. Time is T. But they squared the time there. So you can write here, substitute variables. So from here, anywhere I see S, I put here. I have L. U, I put this. I have LT minus 1. I can put it in bracket. Put T outside, T. Plus half, I repeat it, but it's useless to us. A is what? LT minus 2. And I have T here is what? T here is what? T. T square. And please look up. It's very, very simple. Now from here, I have L. There's nothing for me to do with L here. It's still there. Now this is my left hand side. On my left hand side, I have only L. Now from this side now, what will I do? I have that L. There's nothing for me to do with L here. There's nothing. There's practically nothing here. So I have L 20 add power. So minus 1 plus 1. I have here plus half. Yeah, I'll pick one L. There's no other L here. I have T and T, I'll pick one. Minus 2 plus, because this bracket means times. So minus 2 plus 2. I'm done with second step. Third step, we have L. From here, I bring back my L. There's a law of indices that says A raised to the power of 0 is what? 1. You should know that. 200 raised to the power of 0 is what? 1. So from here, I'll come here. I have T raised to the power of minus 1 plus 1 is what? 0. Because minus times plus is minus. 1 minus 1 is 0. There's nothing like minus 0. So I have plus. I bring back my half. L. Minus 2 plus 2 give us what? 0. I have that. Now from here, I have L is equals to T raised to the power of 0 is 1. So I have L bracket 1 plus half. L. T raised to the power of 0 is what? 1. From here, I have L is equals to 1 times L is what? L plus half. 1 times L is what? L. Now, looking at this, some of us will think, the option is not there, or this is not there. This is your dimension. It shows that the formula is what? Correct. Because what is in the left-hand side is what is in the right-hand side. You can see it. L here is raised to the power of 1, L here is raised to the power of 1, L here is raised to the power of 1. So these guys are what? Dimensionless. Here they become useless. Do you understand? So it's practically like me writing L equals to LL. Everything here is what? The same. What is in the left hand side is what is in the right hand side. That is the theorem for this. That is the theorem for this. I'm very sure they'll give you something like this. They'll give you one of the laws of motion to fulfill that the motions are correct, that the laws are correct. So I'll clean this. I'll give you 2 minutes. When you clean this, then we'll solve the last one for the day. Now I'll beg you to go and get questions. Go and get questions. In the next class, I'll give us CBT questions. CBT questions from year 1, and we are going to play with it. I want to prove the universal gravity. Alright, so you are given this question, and know how, I'm very sure, you'll be asked to prove. You should find the constant. You should find the dimension for the constant. So for us to find the dimension for this guy, first you must make this guy alone. So for us to keep this guy alone here, we have equality sign. And when we have equality sign between two fractions, we cross multiply. So by cross multiply, I have f r squared is equals to g m1 m2. From here, I'm looking for g, so I can divide both sides by what? m1 M2 all over what? M1, M2. This cancel this. So I have G equals to what? I have F R square M1, M2, which is this is force times radius all over double masses. So from here, I'll go and find my what? My variables. So I have the F. Remember, what is the dimension for F? You have MLT minus 2. What is the dimension for radius? This way problem comes. So now, if I have a circle, radius is a line that divides from the center of the circle to any point. Please, radius must not always be here. Radius can 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 even be here. It's not a must that it must go to this side. It's not a must. It's from the center of the circle to any point of the circumference. That's the law. So since my radius is squared here, if I have A here and B here, there's a distance between here and here. So you have the dimension as what? L. So if they square here, I also square my what? L, which is the dimension. Next one is M, which is the mass. Mass is still what? M. The other one is still what? M. So I just put in my variables. From here, I have that G is equals to F. Look at what forces. MLT minus 2. Can put it in bracket. My R is what? L squared. Because my R is square here, which is the radius. All over. My M is still M. So if I do M times M, it's supposed to give me what? M squared. Now, let's get this done here. You can use the CBT method I taught you. From here, okay, let's expand this first. So if I expand this, I'm bringing it here. If I expand this, M does not have anything to multiply here. I'll bring M outside. L has what to multiply here. So I have 1 times, I'll pick 1 L. I'll add powers when there's times. So I have 1 times L. So I'll add powers 1 plus 2. I have here 3. Then there's nothing to multiply with T. I have T raised to the power of what? Minus 2. All over M raised to the power of 2. Now looking at this, I can choose to use the law I just taught you. I have here 1 minus 2. That is 1 division change to minus 2. So if I pick 1 M here, I have 1 minus 2 give me minus 1. I have L raised to the power of 3, T raised to the power of minus 2. This becomes my dimension for what? G. Or let's use the second method. Using the second method, push out the numerator. I have M L raised to the power of 3, T raised to the power of minus 2 times 1 all over M squared. I have this. So from here, I have M L raised to the power of 3, T raised to the power of minus 2 times, invert this, I have M raised to the power of minus 2. So from here, I can choose to have M here, I'll pick 1. Add powers 1 plus minus 2, give me what? Minus 1. 1 plus minus 2. Plus times minus is minus 1 minus 2, give you what? Minus 1. So you have minus 1. L does not have anything to multiply with, you have 3. T does not have anything to multiply with, you have minus 2. So therefore, gravitational constant is equals to what? M minus 1, L raised to the power of 3, T minus 2. This is what you'll be asked in your semester exams. You'll be asked to prove or find G, which is the constant. And this is your answer. So please, we are going to stop here for today. We're going to stop here for today. And before, if you know you enjoyed the video, first thing I want you to do is to subscribe, like, comment, and share to your friends. There are many people that do not understand what to do here. I'll be dropping videos each day. Every day I'll be dropping a video. Tomorrow I'll be doing Chem 101. So I'll be dropping videos every day on that channel. Try to join. This is Defortune's Academy. I will try my best to detail every topic to your understanding. So what I want you to do for me is to subscribe, share, and like the video. I remain Defortune's Academy. See you next week.